Chapter 10, number 21. We've got a pottery wheel. And on that pottery wheel, we've got a very small wheel that can turn with an angular acceleration of 7.2 radians per second squared. The question is, we want to get the big wheel to 65 revolutions per minute. And what acceleration, first they add acceleration, that would be that angular acceleration. And then how much time would it take to get it up to that angular velocity? So, part one. Well, I know that for a tangential acceleration is the rate times the angular acceleration. The reason I'm looking at tangential acceleration is if I find out just how fast the acceleration is at the rim of the small wheel, that will be the exact same number of the acceleration at the rim of the outside wheel. The tangential acceleration will be the same. Alright, so let's find out what the tangential acceleration is for the first wheel. We plug the numbers in, where R, this is R1, this is alpha 1, and we get 0.14 meters per second squared. Okay. So now we want to find what the angular acceleration is for the second wheel. So we can take this angular acceleration wheel. So that'll be the identical tangential acceleration divided by radius 2, the radius of the big wheel. We plug those numbers in, 0.144 meters per second squared divided 0.21 meters, and that gives us 0.6857 14286 radians per second. But keeping in with the significant figures, that's 0.69 radians per second squared. We're done with part A. Part is how much time it takes to get to 65 revolutions per minute, which we know I converted to radians per second, 6.8. So looking at the formulas, we want to find how much time it takes. I'm going to use this formula. Look in my toolbox, compare what I have given, the one thing that's missing. I know the final angular velocity, I know the initial angular velocity arrow, and I now know the angular acceleration, 0.69 or 6857. I have to use that whole big one. So, what's the time? Let's solve for t. Whoops. Okay. If we plug in numbers, we get 9.92656011 seconds. Keep the significant figure, so that's 9.9 seconds. Done.